All right, so this is block 1, sorry. We are going to be learning about verifying if two functions are inverses. So I put up two very simple inverses. So if you look at the two different functions, f and g, these are inverses, is what we are trying to check. Remember, inverses, so g would then undo what f did. F undoes what g did. So they are inverses. So if you can think about it as a stacked function machine, if I put a value into f of x, whatever gets out gets put into g, and you should get out the same if they are inverses. So let's do f of 3 like it says here, and you are going to plug a 3 in for where x is. So 3 plus 3 is 6. Now, whatever you get out is what you put into the g function. So then this becomes g of 6, which is 6 minus 3, which is 3. So your input into your function becomes the output of the inverse function. Remember, your inputs become your outputs, and your outputs become your inputs. So here it just flipped. Okay? Think about it as a table. 3 was my x, 6 was my y, and then vice versa. 6 is my y, or my x, and 3 is my y. Okay? So why don't you try? Now let's plug in, instead of a 3, let's do a 4. Okay? So you are finding f of 4, and then figuring out what, putting your output into your g function. Okay? So I will pause it. You pause the video, and then alright, so you should have gotten 7 for the first function, first output. So then you put a 7 in for the g function, so you get a 4. So these two are inverses. Okay? Now another way to write this is I put g of f of 3. Okay? So this is called composite functions. So how you write, we put f of 3 into, so f of 3 is 6, right? F of 3 equals 6. You put 6 into the g function, okay? So if you see, sorry, I was trying to find a highlighter. I'll get it. This equals 3. Okay? So eventually you put this into here, and then we get out a 3. 3 is put into the f function. So that's this whole piece gets put into, this was the 6, and it gets put into the g function. So then we get out a 3. So let's say g of f of 2. What do you think you get out? You get out a 2. This one over here, we did g of f of 4. So we got out at the end, we got a 4. Okay? So now, let's say g of f of a. What would we get out if you put an a in for x? You should get out an a if they're inverses, remember? So now, if I would put in an x, you should get out an x. So now the problem with numbers. So the numbers work. So this, I put in a 3, I get out a 3, so therefore these two are inverses. But you can't check every single number. If you would check every single number, you would be in Algebra 2 forever. You don't want to be in Algebra 2 forever, because you would have to check every single number ever, which is infinitely many numbers. Decimals, negatives, crazy decimals, crazy fractions, crazy negatives, crazy big numbers, crazy small numbers, all of them you would still have to check, because what if the 3 was just a fluke? What if the 4 was just, it worked for that one, but it didn't work for other ones? So instead of being in Algebra 2 forever, instead of trying to check every single possible, we can put in, we'll just use x, because you can plug in any number for x. So if you do this, or you could do a or any variable, but we're going to just stick with x. So you are going to pick or do x and see, does this simplify down to x? Okay, so here is an example here, and I forgot to put your g of x. So here is our two functions, and we are verifying if they are inverses of each other. Okay? So now let's think about so we've been talking about g of f. Now if I would reverse it and do f of g, it'll be the same thing. It does not matter. So this right here, those are going to be the same thing. Because remember, if G undoes F and F undoes G, they're going to get the same. So let's just double check here. So let's do, if I would do G first, G of 4 over here. So I put 4 plus 1 over 2, which is 5 over 2, which is 2.5. Okay. Now I plug that into my f function, 2.5, so that means 2 times 2.5 minus 1. Well, 2 times 2.5 is 5. 5 minus 1 is 4. So it works. Okay? So this is just either way. You do not have to do it both ways. You can just do it one way. So if I have here, I'm just going to do the top one since we've been working with that. So G, I'm going to color code it to make it easier. Okay, so G of f of x. So my first, normally, remember if I do f of 4, I plugged a 4 in for x. If I did g of 7, I did 7 in for x. So if I do g of f of x, now I'm going to put f of x in for my x value. So I'm going to write down this whole thing, but instead of x, now I have f of x. Okay? So, we are replacing the x, just like this right here, remember, g of x, with f of x. So now, I am going to write this whole thing, but now instead of f of x, this whole thing, remember, is f of x. So now, I'm going to do the cubed root of 2x minus 1 cubed all over 2 plus 1. Okay? Now, when I simplify, I am going to see what can cancel out, what can undo each other. Okay? So I'm not moving things over to the other side, so I'm not subtracting 1 or anything like that. I'm just looking here. Do you see that there's a 2 and a 2? And canceling them in the correct order is important. So 2 over 2 is a big giant 1. So those cancel out. So now I'm left with the cubed root of x minus 1 cubed plus 1. Now, the cube root and the cube, those cancel each other out. So I'm left with x minus 1 plus 1. And now, there is. So my final answer, so then if I get an x, I say, yes, f of x and g of x are inverses of each other. Whoops, you can't see that. There we go. So now, that would be I verified that g and f are inverses. Okay? Because numbers only say 4 only works. Okay? 4 works this way. This one only 3 worked. So you don't have every single value of every number that can make it true. So this shows that every value of x would make these inverses. Okay? Alright, so we're going to do a couple more and then you're going to do some. Okay, so here is ones that you are going to see if you can verify are these inverses. Okay? So, I'm going to do it the opposite way. F of, I'm going to color code again. So, you are going to find f of g of x. So I want you to write the f function, but instead of x, I want you to write g of x. And that's it. Okay? So, do that now. Pause the video, try it, and then see if you can replace the g of x with g of x, and see if you can get that done, and then start the. Alright, so this is what you should have had at this time. So I put in my f function, which is up here, instead of the x, I put g of x. So that's all I did. And then my next step, I put this g of x into here. Okay? Now we look to see what we can cancel out. See, is there anything that undoes each other. So here I see a 2 and a 2. So multiply by 2, divide by 2. So I'm left with 3x minus 5 here, and then minus 4 all over 3 plus 5. Now I combine like terms. So this is minus 9, so 3x minus 9 over 3 plus 5. So now I look here. when you have two things divided by one thing, you divide here and you divide here. So 3x divided by 3 is x. Negative 9 over 3 is negative 3 plus 5. So that gives me x plus 2. So does that mean that these two are inverses? Because I did not get x, that means these two are not inverses of each other. Okay? So, sometimes you are going to get, no, not all inverses are, or not all problems I'm going to give you are inverses. Okay? Okay, so now you have 3 problems that I want you to try. These are from the book. So you have these, you are verifying, are these two inverses? Are these two inverses? And are these two inverses? Okay? So it's A, B, and C. You are verifying, remember, you can verify either f of g of x, and it will give you x. Or you are verifying g of f of x. And if it does equal x, that means that they are inverses. Okay? I am going to post 3 videos or 3 pictures of the answers of all of these. And remember, go to your teacher's office hours to get help. They will have them posted. You will have 2 hours, so go use your resources well. And good luck.